Okay, picking up with the January 2019 exam, right where we left off, which is question 33, which begins the part 3 section of the exam. There are 4 part 3 questions, and they are each 4 points now, so probably more work is involved, or there's more parts involved in solving them. But once again, just to reiterate from the last video, make sure you show all of your work to ensure that you receive full credit on questions. So, number 33, starting right off, says to solve the following system of equations algebraically for all values of a, b, and c. So I have a 3x3 system here, and what you want to look out for first, is that everything is lined up so that you can use elimination. So what I mean by lined up is like these first two. A is over A, B is over B, C is over C, equals, number. Everything is lined up, but there's a problem with my third equation. It's not lined up. It's not too hard to get it lined up. I just want this A to be over here. So it's a positive A. I'm going to subtract the A over, and now I have negative A, then the plus 6B, then the plus 2C equals 14. So once I move that A over, it really is in the right format and didn't take me too long. So that third equation is now this one. So to organize my work a little bit, I'm going to label these A, B, and C, and then we're going to come over here and say that I am doing step 1. So I do also want to side note real quick and say there are a lot of different ways that you can solve examples like this. You can start by eliminating the B's, you can start by eliminating the C's. It is entirely up to you what you tackle first. I'm going to take the path that I think is the easiest, or the least extra work. So I'm going to start by picking equations A and C. The reason I want to pick A and C is because when I put A and C together, there's a positive A here and a negative A here, and I know that when I use my elimination method and add those two equations together, it'll eliminate my A, which is exactly what I wanted to happen. So this equation, I'm just going to rewrite it to show all of my work nice and organized, ends up getting me that, and then negative A plus 6b plus 2c equals 14. Okay, so now that I picked those two equations with the goal of eliminating a variable, I'm going to add them together and actually eliminate it. So the a's cancel out. I get 10b plus 8c equals 37. Now, to organize my work like we did in class, I'm going to call that equation D. And now I'm up to step 2. Step 2 is the exact same thing. I just have to pick two different equations, but you still have to cancel the same variable. So I'm going to say that again. Step 2 is the exact same step. You pick two different equations, but you still have to cancel out the same variable. So it does not matter which ones you pick. I'm going to pick B and C because B has a positive A and a negative A. So when I put those together, they're going to cancel. So I want B and C. B is A plus 2B plus C equals 2. Equation C, again, just rewriting it to show all of my work, is this. No, it's not. I just copied the wrong one. Oh my. Plus 2B plus C. Okay. What did I do? Did I copy the exact same equation twice? Oh my gosh, I did. C is that red one, negative A plus 6B plus 2C equals 14. Sorry about that. Now I'm going to do what I did in step 1 and add the two equations together with the goal of canceling out the A, and they do. So 2b plus 6b is 8b, and then 1c plus 2c is a plus 3c, and that equals 16. I'm going to call this equation E. So now your third step, what you just did in steps 1 and 2 is you created two equations that are in two variables. So when I put them together, I will now have a 2 by 2 system. So I'm going to put the D and E together. This is 10b plus 8c equals 37. And again, I'm writing them to show all of my work. I also don't want to make any mistakes. So if I keep rewriting the equations over and over again, I'm less likely to do something in my head and make a mistake. Okay, so I have 10b, 8c, and I have 8b and 3c. So this part is kind of a bummer, because I would try to add these equations together. Obviously nothing cancels, and it's not as easy to cancel something out as it was with the A's and the negative A's. So if I'm trying to cancel out this 10, I would need this 8 to be a negative 10, and I can't multiply 8 by anything nicely to turn it into a negative 10. And kind of the same idea with the C is if I wanted to cancel C, I can't multiply 3 by anything nicely to turn it into the negative 8 that I need it to be to cancel with that positive 8. So because these c's have smaller numbers, I'm going to cancel the c's, but unfortunately what it means is I need to multiply both equations by a number. Here's the trick that works every single time. Just moving that over so I have some more space. Again, I'm going to try and cancel the c's. So I'm going to put a 3 out in front of this one because 3 times 8 will get me 24. And I'm going to put an 8 out in front of this one. Put an 8 out in front of this one because, again, 8 times 3 is 24. But I can't have two positive 24s. Doesn't matter which one you make negative. I'm going to make the bottom one negative. And now I have to distribute a lot through. So 3 times 10b is going to be 30b. 3 times 8c is a plus 24c. And then 3 times 37 is 111. Now I distribute my negative 8 through. That'll get me a negative 64b. Negative 8 times 3c is the negative 24c that I needed it to be. And then when I multiply 8 by 16, I get 128. But that is a negative 128 because it was a negative 8. Missing even just one negative can make or break the whole rest of your problem, which is a lot more work, so be very careful. And I'm going to add these together, and the c's eliminate. I could have done the b's and multiplied this by an 8 and this by a negative 10. That's what I'm saying. There's so many different paths. I'm just taking the path that, I would have taken if I was taking the exam. So now I'm going to combine my like terms by adding. This is going to get me a negative 34b. Again, my c's canceled, and then 111 minus 128 is a negative 17. So I need to solve this for b. Now that I have one variable finally, I'm going to do that by dividing by negative 34, and I get that b is a positive 0.5, or you can write 1/2. Okay, so this is part of my answer. It's only one variable, but once you find one, you are in great shape to find the rest. Equations d and e are in just two variables, and they have a b and a c in them. So now that I know what b is, I can plug b into my equations here or here, either one, whatever one you think is easier, for step 4, and that'll help me find my next variable, which will be c. So I'm going to use equation e. Equation e is 8b plus 3c equals 16, and I'm going to take that b value and plug it in place of b. So this will be 8 times 0.5 plus 3c equals 16. So I multiply these all out. Half of 8 is 4, plus 3c equals 16. Subtract the 4 over, I get 3c equals 12, and then divide by 3, and I get c equals 4. And now I have two of the variables that I need. My last step is to now find a. So I'm going to go back up to my original equations, pick whichever one you think is the easiest. I'm going to use b for this one, which is a plus 2b plus c. This is step 5, and my final step, I forgot it again, a plus 2b plus c. A plus 2b plus c equals 2. A plus 2b plus c equals 2. Great. And I'm going to plug the two variables that I have in. So b is 0.5. So I'm going to put the 0.5 here. And c is 4. So I'm going to put the 4 here. Everything else is going to come down. So this is 2 times 0.5. And the plus goes there. So now when I simplify this, this is a plus half of 2 is 1 plus 4 equals 2. So I get a plus 5 equals 2, and then when I subtract the 5 over, I get a equals negative 3, and that is my third and final variable. So a, b, and c are found. That is my final answer. I'm going to write it as in order, a, b, c. It's negative 3, comma b, which is 0.5, or you could write 1/2, and then c is 4, and that is my final answer. Finally made it. On to number 34. But that's why it's a heftier question, guys. 4 points. It was worth it. All right. Some other advice I have for this as well is don't ever stop. Even if you think you made a mistake, like maybe you got like a crazy answer for this one, obviously go back and try and find a mistake, but don't just give up. Continue solving to find the rest of them, because if you only make one mistake, obviously you won't lose like full credit versus if you just give up and you'll lose more credit for that. All right, 34, given a of x equals x to the 4th plus 2x cubed plus 4x minus 10, and b of x equals blah, determine a of x divided by b of x in the form blah. This right here is a huge indicator that I'm going to have to do long division. So if I do long division with this, I'm dividing by the x plus 2. That's going to go on the outside. And underneath here, I'm going to put x to the 4th plus 2x cubed, and then I realize I'm missing a term in here. I'm going to put in the plus 0x squared and then bring the rest down. That step is not necessary, but I do think it helps you later on when you're trying to add together x squared terms here, so that you don't make a mistake and accidentally add it to this guy. All right, so the thought process you need to go through for starting long division is, what would I have to multiply this by to turn it into this? I would have to multiply an x by an x to the third, so that's going to go on top, x to the third. Now I have to multiply that through to both of these. X to the third times x to the, times x is just x to the fourth, and x to the third times 2 is a plus 2x to the third. Now every time you end up at this step, your next step is to subtract that line. I am subtracting the whole thing, so they both become subtraction. This will cancel, and this is kind of weird, but this one cancels too. That means for my next step, I'm going to have to bring down 2 terms to make this work. So it's going to be a plus 0x squared, and then a plus 4x. This one was super weird. Okay, so I'm going to walk you through that thought process again. Even though this one's weird, I have to figure out what I have to multiply this by to turn it into this. I'm going to have to multiply that by a 0x. Super weird. So I'm just going to put a 0x up here to kind of use it as a placeholder, and then multiply it through to both of these things. 0 times x is a 0x, so this is going to be 0x squared. And then 0x times 2 is going to be a plus 0x, or just plus 0. It's all plus 0 anyway. It doesn't really make a difference, but here's where it gets a little tricky. I am subtracting this row right here. So when I subtract these, this cancels, which was my intention, but these don't cancel. I am going to bring down the 4x because 4x minus nothing, technically there's nothing here, means the 4x needs to come down. And then my next step is to bring down the minus 10, and now I have to take one more journey through this long division process. So once again, what do I have to multiply this x by to turn it into this, which is a 4x? That's going to be a 4. So I got away from my zeros, thank goodness. I'm going to put a 4 on top and then multiply that 4 through. 4 times x is 4x, and 4 times 2 is a plus 8. But once again, I am subtracting this whole line, so they both become subtraction. This will cancel, and I will have negative 18 as my remainder. So because this plus 0x is just 0, that whole term goes away, which means that when I go to write it now in this form, I write my quotient first. My quotient is x squared plus 4, plus my remainder, which is a negative 18, and that's over b of x, and b of x was what I was dividing by, which is x plus 2. So the x plus 2 goes on the bottom, and this is my final answer. We made it. One other little tiny tip, if you wanted to do this, because it's plus and negative, you could just put a minus here. Either answer would be correct. Oh, we did not finish this question. There's a part B. It says, is b of x a factor of a of x? Remember, to be a factor, it means it goes into the function evenly or perfectly with no remainder. So this one, because it had a remainder of negative 18, it is not a factor. And to explain means you need to use your words. Explain means use words. So I want to say, because there was a remainder of negative 18 when a of x divided by b of x. Then I'm also going to say, to be a factor, there would be a remainder of 0. So if I did get a remainder of 0, the answer would have been yes, but I didn't, so the answer was no. So just kind of the advice that I give every year, anytime an example says to explain, again, that means you need to use your words, but what I want you to do when you have to explain something is pretend that you are me. You are the math teacher and you are teaching someone like how this works. You can't just say no because the remainder is 18, because that doesn't give the full picture. You're going to say no, the remainder was 18, and in order to be a factor, the remainder would have to be 0. You have to give full detail and explain it as though you are a teacher. All right, number 35. A radio station claims to its advertisers that the mean number of minute commuters, oh wow, that was hard. Mean number of minutes commuters listen to listen to the station is 30. Sorry. So the radio station claims to its advertisers that the mean, which means average number of minutes that commuters listen to the station is 30. So the average number of minutes that someone who's driving listens to the radio is 30. The station conducted a survey of 500 of their listeners who commute. The sample statistics are shown below. So of these specific 500, they ended up with an average of 29.11 minutes that they listened to the radio. So then, we talked about this in class. A simulation is like kind of fake test results based on your original results. So a simulation was run 1,000 times. It's almost like it's a replacement for actually doing a survey 1,000 times to 500 people. It'd be way too much. So they do simulations instead. The computer generated it, and these are the results, all up here. So based on the simulation results, aka these things right here, is the claim that commuters listen to the station on average 30 minutes plausible? Plausible means likely, usual, or in other words, they're saying that plausible is in the middle 95. Explain your response, including an interval containing the middle 95% of data rounded to the nearest hundredth. So the first thing I need to do is find the middle 95. The formula for that is to take the average, add and subtract 2 standard deviations. Okay, so I'm taking the information from the simulation, which is all of this right here, and I'm plugging it into my formula. The mean is my x bar, so that's going to be 29.101 plus or minus 2 times the standard deviation, which is 0.934. Remember, the plus or minus is going to give me 2 separate values. I'm going to subtract first and then add. When I subtract them, I get 27.233. When I add them, I get 30.969. If you need time to practice plugging that in, please pause the video. But this is an interval, so it's that number through that number. Now, to the nearest hundredth means 2 places after the decimal point. This 3 does not bump that up, so it's going to be 27.23 through. This one, same idea, 2 places after the decimal point, but the 9 bumps this one up, so it's 30.97. So that is my interval that it does not answer the question, but it does help me answer the question. Just a little side note, you can also put an interval like this. It'd be 27.23, comma, 30.97. Okay, either way you do the interval is fine, but now to get back to the question. It says, using that middle 95% and the simulation results, is the claim that commuters listen to the radio station on average 30 minutes plausible? So I have to look at my interval. 30 minutes falls inside of the interval. Barely, it's like right there, but it does. And since it does, it is a plausible occurrence. So I'm going to say yes. And then it says explain. Explain means words. So 30 minutes is plausible. Simply because it falls inside the middle 95%. Perfect, 2 more. So number 36, solve the given equation algebraically for all values of x. Whenever you are solving a square root equation, you want to try and get the square root by itself. So my first step for this one is to move that minus 2x over by adding the 2x. So that'll cancel and I'll be left with 3 radical x equals. These cannot combine, so I'm just going to bring them down, and just because I like how it looks better, I'm going to put the 2x first, then the minus 5. Now, I'm going to write in red right now, and I don't want you to copy this down. I just want you to hear me out. To get the square root by itself, you'd have to divide everything by 3. So I would be left with the square root of x equals 2 over 3x minus 5 over 3. And then, again, still in red, your next step would be to square both sides. I don't know about you, but I don't want to square that. That means this times this, and then double distribute that out. Once that starts to happen, you kind of like steer away from that, because then you're going to have to factor that with fractions. No, thank you. So I'm going to get rid of my red. I was just showing you a path that may have been taken by you. that maybe you would want to like backtrack and not do. What I'm going to do instead is square both sides now. When I square this side and square this side, first of all, on this side, we're very good at these. I have to write this out twice. On the left side, I am squaring both pieces of this. So 3 squared is 9, and the square root of x squared, remember square roots and squareds cancel each other out, it'll just be an x. That is a lot better. I like that a lot better. Next thing I'm going to do is multiply this out now. So the 9x comes down, it equals 2x times 2x is 4x squared. I'm going to use my shortcut for this next step. When I do 2x times negative 5, I get a negative 10x. Negative 5 times 2x is a minus 10x, so when I combine those, I get negative 20x, and then negative 5 times negative 5 is a plus 25. And because I have an x squared and an x, I'm going to have to factor to solve this, but you can't factor until you're equal to 0, so I'm going to subtract that 9x over. So I get 4x squared minus 29x plus 25 equals 0. Okay, so when I go to tackle solving this, what you want to do is look at your directions. If the directions say to round your answer, or if they say simplest radical form, that means it doesn't factor and you would have to use the quadratic formula. This one does not say that, so I can factor it, but it's a yucky one to factor. If you don't want to factor something like this, where it's AC, the quadratic formula always works. So we have a choice right now. I'm going to go through factoring it, but if you want to just use the quadratic formula, go for it. It is on the reference sheet. Pull that out and give it a try. Like I said, I'm going to factor it though. So this is AC. I looked for a GCF first and I can't take one out, so I'm stuck doing AC, which means I multiply the A and the C together first, and that gets me 100. So I need the numbers that multiply to 100 that add to negative 29. Those numbers are going to be 4 and 25. However, those would add to a positive 29, and I have a negative 29, so I'm going to have to make both of them negative. And I know that pair works because a negative times a negative gets me the positive 100, and when I add them together, I get the negative 29. Now, my factors are not x minus 4, x minus 25. That does not work. That is the easy method. I have to do AC, which means bring down the first term, 4x squared, split up the middle term into a minus 4x minus 25x, and then bring down the last term, plus 25 equals 0. Now that I have 4 terms, I'm going to group the first 2 and group the second 2 and GCF each group. GCF of my first group is 4x, which leaves me with x minus 1, and the GCF of my second group is negative 25. It has to be a negative 25 because these negatives will cancel and leave me with a positive x. This positive divided by a negative will leave me with a negative 1, and the whole goal for grouping is to make those match up, so it had to be a negative 25. So now I'm going to bring down, I'm going to bring down the one that they have in common, but you only bring it down once as a GCF, so those are gone. And then you put your 2 GCFs from the grouping section together. This is 4x minus 25, and that equals 0. I cannot factor it anymore. It is factored completely, so I'm at the step where I'm going to tee it up. So I get x minus 1 equals 0, and 4x minus 25 equals 0. So this will get me a 1. When I add the 25 over here and then divide by 4, I get positive 25 over 4. So I got 2 answers, which is awesome. However, there are 3 situations where you need to check, and one of them is when you are solving a square root equation. The other 2 are fractional equations and log equations. But for now, I know I need to check because I have a square root equation. So when I check, it means I have to plug into the original equation. So my original equation was 3 square root of x minus 2x equals negative 5. So first I'm going to check the 1. This will be 3 times the square root of 1 minus 2 times 1 equals negative 5. So you do that math on the left side. It's 3 times 1 minus 2. It's going to be a 1. 1 does not equal negative 5, so that means that this answer rejects, and it is not 1. I check the next one. 3 times the square root of 25 over 4 minus 2 times 25 over 4 equals negative 5. You can plug that into your calculator. You can trust me though, it is negative 5 equals negative 5. That does check. Please do practice plugging it in your calculator to make sure you get negative 5. There's a lot of fractions going on. Fractions go in parentheses. So that answer does work. That means that is my final answer. I'm just going to box it in there, or you can put it in your squiggly wigglies, 25 over 4. But do not forget to check. One of the answers is not actually one of the answers. All right, last one. We are now on the part 4. The part 4, there's only one of them, but it is 6 points. So it is a hefty question. Once again, just a reminder, show all work. So it says Tony is evaluating his retirement savings. He currently has $318,000 in his account, which earns an interest rate of 7% compounded annually. He wants to determine how much he will have in the account in the future, even if he makes no additional contributions to the account. Write a function a of t to represent the amount of money that will be in his account in t years. Because this is a compounded problem, I want to use my compounded interest formula, which is this one. I am not using PERT for this one because it is not compounded continuously. You only use PERT when it is compounded continuously, otherwise you use this one. So when I go to write out my function, it tells me to use a of t, which means this needs to be a of t equals my starting amount is what he currently has in the account, which is $318,000 times 1 plus. The rate is 7%, but you have to plug it in as a decimal, so it's 0.07 over, now this one's kind of tricky, but it's compounded annually. Compounded, or your n, is how often something happens in a year. Annually is once every year, so it's going to be a 1 to the 1 times t. It doesn't tell me what t is, so I just plug in t. And then I'm going to simplify this a little bit because this divided by 1 is just 0.07. So this is, let me do it down here so I have enough space. A of t equals 318,000 times 1.07 to the t. That's my answer for this first part. All right, now here's where the fun really comes in. It says graph a of t where 0 is less than or equal to t is less than or equal to 20 on the set of axes below. There's a lot involved in this, but a graphing question is just a matter of plugging it into your calculator. Now, since I have to graph it from 0 to 20, that means I have 0, 1, 2, Good times. Good times. Graphing it from 0 to 20. Now, that means that my x-axis needs to go from 0 to 20. You want to count out your boxes first. I already did. You can trust me. There are 20, so I'm going to label these all the way to 20. Now, you guys can do like every 5 boxes labeled, but it'll help you to graph it if you have them all labeled. So really, it's a matter of preference. I like to have all of the numbers labeled just so if I'm looking for 17, I don't have to think about it. It's just there. Okay, now to label, this is t, and it's years. Okay, to label my y-axis, which is a of t, it is going to be the money in the account. I'm just going to call it a of t here as well, even though it's already labeled there. I just want to go above and beyond to do fantastic on my part 4. But when it comes to labeling your y-axis, you need to know what numbers you need, and that means I need to know this over here. So I'm going to plug this into my calculator now and to pull up the table. So go to my y, I go to my y equals and I clear it out, and I have to type my equation in. So it was 318,000. See how important it is to have the right equation up here though? Could you imagine if I forgot my compounded interest formula and then I didn't have the right thing and now I have to graph it? It's important that we know our formula is so important. So I plug this in using an x instead of a t. And then you can hit your graph to see what it's supposed to look like, but since our axis goes out to 20, you will have to adjust your window. For now, I'm just going to pull up the table so I can see what kind of numbers I have. This app is not fantastic for this. You will not have the dots. You'll be able to see full numbers. But as of now, this is what we're looking at. So these are the values I need. I have to go from 318,000 as my low, so 318,000 for 0, all the way up to 20, which I'm sorry you can't see it on my calculator, but I am just going to copy it from my key. I need more space. Why did I make my table so far over? That was not very smart. So I'm just going to slide it over. There we go. So my 20 has a value of 1, 2, 3, 0, 5, 5, 9.659. Okay. Ew. So you need to know what that number is. I have 1, 2, 3, 4, 5, 6, 7 digits. So when you put your commas in, this is 1,230,559, which means my y-axis needs to get up to 1 million. Actually, further than that, because I have 1,230,000. So you want to try and figure out what scale you want to go up by. If you want to take a second to think about it, please pause the video. You are going to want to go up by 100,000 each time. So this is going to be 100,000, 200,000, 300,000, and so on. This is 400,000, 500,000, 600,000, 7, 8, 900,000. Don't actually do what I'm doing. I'm just shorthanding it. All the way up until you get to 1,300,000, because I need to go to at least that to fit this. So the reason I stopped labeling mine is because I'm getting a little lazy, I suppose, but I already did it and I just kind of scanned it in. So you can look at my scale now. This is my scale over here. I have it fully labeled and I have my full table drawn. So obviously that is a lot of points. I went above and beyond just to show you my graph. But you don't have to plot every single one of those points. You just have to get enough points to make a good graph. So since I have to graph it from 0 to 20, you'll notice over here I circled some points. So I have circled, that's not, okay, we're not going to highlight, we're just going to circle again. I circled every 5. If you plot these that are circled, that is plenty to get a good graph. So that would have just been this point, this, oh, not that one. Come on, there we go. This point, 10, 15, no, oh my God, why do I keep missing? 15, and then 20. If I had just those 5 points, that would have been plenty to graph. So please, guys, don't worry about all of these. You just want to graph enough points to get a good representation of the graph. So obviously, you're going to have to pause the video at this point to take the time to plot at least those 5 points. But I just got these points from the table. Then I plot the points, make sure your scale is there, your labels on your axes are good, and this is crucial. Since it told me to only graph from 0 to 20, you do not put an arrow here. I know on your calculator it continues forever, but no, it's telling me just graph from 0 through 20. That means it ends here, and that's all it cares about. Do not put an arrow on this graph. Okay, now that I showed you the graph, I'm going to go back to the exam. Perfect, it deleted all my stuff. Love it so much. Doesn't matter because we are going on to the next page. Do know it does tell you if it's continued on the next page, so make sure you read, and I'm going on to the next one. So Tony's goal is to save 1 million. Determine algebraically to the nearest year how many years it will take to achieve his goal. So what I'm going to do first, just so I have it, is copy this equation from the part A above, or on the last page I should say. 1.07 to the t. Now, it's asking me to determine how many years. That means I'm solving for t, because up here it told me to use t for time. So if I'm solving for the amount of years, that means I'm solving for t. And if I'm solving for t, that means I have to plug in for the a of t. And a of t represents, where did it tell me? The amount of money in the account. So if I have to plug in for a of t to help me solve for t, and his goal is to save 1 million, that means I'm plugging in 1 million right here. So 1 million, make sure you write the correct amount of zeros. There are 6 zeros there. And I'm going to just copy down the rest of this equation. Okay. Super important that we know this. When there's a variable in the exponent, I have to use logs to solve for it. So I am going to have to use logs, but before I use logs, I have to get what's being raised to the variable by itself. It's like my always how I need to set it up when I'm using logs. So to get that boxed in part by itself, I need to get rid of the 318,000. I notice these are being multiplied, so I'm going to divide by 318,000 on both sides. So when I divide, I get a yucky decimal. I don't want the decimal. Let me just show you. Divided by 318,000. gets that. I don't like that, so I'm going to math enter it, which simplifies to this fraction. If you would prefer to write the decimal, remember you can't round it early, but you can use the whole decimal. I'm just going to use a fraction. It's 500 over 159 equals, since these canceled, I'm just left with 1.07 to the t. That was the part that was boxed in, so now I'm good to go for taking logs. So using logs, I have to write the word log on both sides. This will be the log of 500 over 159 equals, when I take the log of this side, the whole point in taking the log is to bring the exponent to the front so that t comes down, then it's the log of 1.07. So now that I'm solving for t, I need to get rid of the log of 1.07. They are being multiplied, so I have to divide by the log of 1.07, divide by the log of 1.07. So these cancel, and I end up with, let me plug this into my calculator, the log of that divided by the log of 1.07. Gets me that decimal, so I'm going to copy the whole decimal, sorry. Okay, I'm going to copy the whole decimal, which is 16.93359122266, to show that I got that answer, and then I'm going to round it. It told me to round to, what did it say? To the nearest year, so nearest whole number. That's going to be 17 years. Okay, one more part and then we're done. It says, explain how your graph of a of t confirms your answer. So now you need to go back to your graph. It might delete my answer. That's okay. We're going to go back to the graph. It says to explain how your graph confirms that 17 years, so I'm going to look at 17 years, is about 1 million. So I'm going to go to 17 years up to my graph. It is at this point. Even if you didn't plot that point, you would have seen that it goes through that point, and then I look over here. It looks like it hits right at 1 million. So that's what I need to explain on my exam for that last part. So explain how your graph of a of t confirms your answer. I'm going to say specifically the graph contains the point 17,1 million. Okay, and that shows, so which shows the account will reach $1 million after 17 years. And we made it through the last question, that 6-pointer. It was a big one. And that is the end of this exam. So if you guys have questions, like I always say in every video, please feel free to reach out to me on Schoology or Remind, and keep practicing.